Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Barron Brothers.
My name is James Huang.
And we are your hosts for episode number 8, The Chemistry of Acid Rain. Today, we will be discussing why acid rain is so harmful and its effects on the city and the ecosystem.
As the world population continues to increase, the resources required to maintain this population also increase, including factories to make products for consumers, cars for transportation, and food. However, many do not consider the environmental implications just by living in today's world as our environmental situation continues to decline. One of these effects is the increase of acid rain due to the amount of pollutants released by industrial processes and traditional power plants.
You see, non-polluted rainwater is already slightly acidic because the evaporated water reacts naturally with the carbon dioxide in the air, forming carbonic acid. As carbon dioxide reacts with water to form carbonic acid, and carbonic acid reacts with water to form hydronium, H3O+, and the conjugate base. You see, this reaction has two mechanisms, as the conjugate base still has a hydrogen attached to it, so it can react again with hydrogen to produce a carbonate molecule and hydronium. However, this is the result of natural CO2 from the air. Other pollutants, such as sulfate from factories and car emissions, are also a big factor, as sulfur dioxide reacts with oxygen and evaporated water to form something called sulfuric acid, which follows the same structure as carbonic acid. And nitric acid is formed in a similar way and reacts with water again. However, not all acids are created equal, and we measure the strength of an acid by something called a Ka value. A Ka value, well, you see, with these reactions that I described, it doesn't react to completion, as we scientists like to call it. There is still some carbonic acid left over from the carbonic acid reaction. It doesn't all turn into the conjugate base and hydronium. So, with the Ka value, which is a concentration of the products over the concentration of reactants, we can see the strength of an acid. With carbonic acid in particular, the Ka values are very low, so there is a lot of carbonic acid left over compared to nitric acid and especially sulfuric acid. These last two acids are very strong, so it is no wonder that the pH of regular rain, which is 5.6, is much higher than that of acid rain, which usually ranges from 4.2 to 4.4. Also, we should note that the pH is something called a logarithmic scale. So the difference in acidity between 7 and 5.6 on the pH scale, which helps us measure the acidity of a certain acid, is much smaller than that of 5.6 to 4.4, even though the difference in pHs may be smaller. Also, carton factory pollution forms additional CO2, producing more carbonic acid, thereby lowering the pH of acid rain even further.
Alright, so now that you know how acid rain is formed, you might be thinking, why is this important? Well, acidic rain reacts with building materials, which causes corrosion. So for example, limestone, which is frequently used in concrete, has the reacts with sulfuric acid to the reaction calcium carbonate plus sulfuric acid combine to form calcium sulfate, carbon dioxide, and water. And in this reaction, the sulfuric acid in the acid rain strips away at the calcium carbonate, which leads to faster weathering compared to normal rain. And solid aluminum reacts with aqueous sulfuric acid to form aluminum ions, sulfate, and hydrogen gas. Notice that the solid aluminum is turned into aqueous aluminum ions. So there's no more solid aluminum left. And over time, this acid rain can cause buildings and other structures to fall apart. When the H3O plus in acid rain mixes with lakes and other bodies of water, the pH of the water will drop, and this will damage the ecosystem. For example, most fish won't hatch if the pH of the water is less than 5. So if enough acid rain is mixed with the water, no more fish will hatch, which can damage ecosystems.
And in addition to concrete, acid rain affects skyscrapers as well, which of course are made of steel. And the vast majority of steel is made up of iron, 97% in fact. So as acid rain falls, iron reacts with the various acids already dissolved in the acid rain and corrodes, not dissimilar to that of aluminum. So take sulfuric acid as an example. We have solid iron from the steel in the skyscraper, and the aqueous sulfuric acid, which is already dissolved in the rain, which reacts with the iron to form iron ions dissolved in this acid rain, sulfate ions, and hydrogen gas. Notice no more iron, which will corrode the skyscrapers and cause structural damage.
So, acid rain is clearly a danger to buildings around the world. However, is there any way to lessen the effects of acid rain? Well, one of the greatest ways to combat the effects of acid rain is to target the source of it all, power plants and factories. One popular way is through limestone injection, where calcium carbonate in limestone is combined with sulfuric acid in smokestacks to produce calcium sulfate and carbonic acid. So what this does is the limestone completely gets rid of all the sulfuric acid in the smokestack. And while this does produce carbonic acid, the Ka of carbonic acid is much lower than the Ka of sulfuric acid. And this means that carbonic acid has less of an effect on the environment as its strength is much lower than sulfuric acid.
In conclusion, the issue of acid rain is paramount because today's society is ignoring global warming and continuing to pollute. If excessive pollution continues, acid rain will become more common. This will cause more damage to ecosystems and buildings and endanger the safety and quality of life for many across the globe. We, as the younger generation, will grow up in this world, so we must pioneer the changes needed, such as regulating factory pollution, basing the economy on electric transportation rather than oil, and creating more green space free from chemical pollution. This is the only way to improve this world for us and all future generations. Thank you for listening to this episode of Chemistry Connections. For more student-run podcasts and digital content, make sure you visit www.hvspn.com.